Hi, am I audible? Hello, hello. Okay, so hello guys, I'm Raghav, and today we will discuss all the four problems of today's Leetcode contest. So just say something in chat so that I can see how many people are actively watching the video right now. And let me see if this working fine. Uh, okay, nice. Hello, Fazan. Sorry for being late for starting the video. We were actually being stuck at some technical issue related to the platform. Okay, so let's start. The very first problem, find the kth element in a string in string game 1. It says that initially Alice and Bob are playing a game, and initially they have a string word which is having only one character, that is A, and we have been given a positive integer k. Now Bob will ask Alice to perform the following operation forever. In the operation, what we do is uh, generate a new string in which each and every character of the word is changed by its next character. I will show what it means, and then we will append that new string to the word. Okay, I think it wouldn't be clear by this. Just 1 second. Yeah, now it's good. Okay, so what the problem is saying is we have been given a word. This is a string. Let's say it is ABC DAB. Then what we will do in one operation is we will create a new string in which for each and every character, like if there is an A here, we will put up a B at that exact same place in the new string. Instead of this B, we will put up a C. Instead of C, we will put up a D. Instead of D, we will put up an E. Instead of A, we will put up B. At the place of B, we will put up C. And let's say if there was Z as well at the end of the string or at any place, at the place of that Z, we will put up A. And this will be the new string which we have generated. Then we will just append this at the back of the original string. So the original string, this word will now become A B C D A B Z B C D E B C A. It will become like this. Guys, does it make sense? What will happen in one operation? So what we will have to do is we will have to return the kth character in the new word whenever that word has got at least k characters. So we will apply this operation again and again and again, and at some point of time, this word will have greater than equal to k number of characters. The length of the word will be greater than equal to k. So in that case, we have to tell what will be the kth character. Guys, does it make sense? Okay, I just messed up. Yeah. And one more thing, initially this word is equal to A. Okay, so guys, please say yes or no in the chat so that I would be sure that whether everyone would have understood the problem statement or not. Or maybe we can again. Okay, now I understood what's the problem. Okay, let's take an example. If k is equal to 5, we would be given only this value of k. In case when k is equal to 5, initially the word would be just A. Then on the next turn, when we would apply one operation on this, uh, the string will become AB because we would have appended b to the string. After that, we will apply another operation. The string will become AB, and then BC would be appended because A becomes B and B becomes C. So AB BC. Then still the length is less than K, so we will apply another operation. The new string will be AB BC, this part, and then BCCD, which is coming up from like in this way. So BCCD, and yeah, this string is having more than K characters. So now we can just look at the fifth character, that is this B. So our answer will be equal to B. And let's say if we have to figure out the 10th character, maybe let's continue from this place. If K was equal to 10, then even at this place, the length of the string would be less than K. So we will apply another operation here. A, B, B, C, B, C, C, D, and then append the string B, C, C, D, C, D, D, E. And the 10th character is this, C. So the answer would be C. So I hope the problem is clear. And the constraints here are very small. The value of K is just 500. Here K is less than equal to 500. So the idea, like for solving the problem, since the constraints are very small, obviously we will try to think about the brute force method first. That maybe just try to solve the problem, don't care about time complexity. So what is the simplest solution you can think of? In my case, what I can think of is I will have a word which is initialized with A, then as long as while the length of this word dot length is less than K, I will just say ki generate a new word, let's say, or maybe let's black box this part for now. As long as the length of the word is less than K, we will just apply operation. For now, let's call this in this way. We will apply operation. And once the length of the word is greater than equal to K, in that case, we will return word of K minus 1, because in C++ and in most of the programming languages, we have zero based indexing. So if K is equal to 1, we will just have to return the character at the index 0. And this is true for languages like C++, Java, JavaScript, Python, and probably for most of the languages. Okay, so now the question is, how will we apply the operation? What we want to do is, if we have a word, something like ABC, then after applying the operation, this word should become equal to ABC, and like we have first of all written the same word and then write B, C, and D. So this is what we want to do. Now there can be multiple ways in which you can do this. One of the ways is you can create a new string, maybe let's say temp with name temp, and go on for each and every character of the actual string of the word. So we will go on for each and every character. Maybe instead of writing the code here, I can just tell about the logic and then we can look at the code later on. So whatever word we have, we will just go for each and every character. Now let us say we are at this character which is equal to D. Then we will just say if this is temp of I, or sorry, word of I equal to D, we can just say temp dot pushback word I plus 1. Yeah, in C++, this thing will work. If you are coding in Java, then the method would be a bit different. You will have to convert this D into E in some other way. Since I don't code in Java, I'm not sure about the way in which we implement it. But the logic is simple. Whatever character you have, you just want to turn it into the next character. If you have anything like A, it should become B. If you have a character like B, this should become C, and so on till Y, it should become Z. And if the character is Z, in that case, it should become A. So the implementation can vary on the basis of which language you code in. I'm talking about the implementation of C++ for now because I code in C++. Um, so in C++, you can directly add +1. So as long as this word of I is from A to Y, it would work fine. But if the word of I is Z, then this will cause some problem for you. So before writing this, you can just have an if condition that if word of I equal to Z, in that case temp dot push back A. I hope it makes sense. Uh, by the way, this is just something related to implementation. Uh, the part which we had to discuss mainly in PCD was this, the logic part. For the part of implementation, one thing which I suggest is try to implement it on your own and don't look at the others' implementations first. And once you have put up a lot of efforts by yourself, maybe you managed to implement it or maybe you failed. In that case, look at others' implementations. So this is just my personal suggestion and it does help a lot. So let me show you my implementation as well. What I did is I created a string. Yeah, in the logic part, we named it as word. Currently in the code, I wrote it as S because it's a shorter name. So while the string is having a length less than K, we will create a new string T, and in T, we will, okay, let me raise. This will also work, but you can write it in a simpler way as well. That if S of I is equal to Z, then T dot push back A, else T dot push back S of I plus 1. Currently, which question? Question number 1. Yeah, see, it's working. And then at the end of the day, we can just push back this new string, and our original string is being updated in this way. So guys, is this problem clear? Does anybody have any doubt? Talking about the space and time complexity. See, the time complexity should be equal to big O of K, and space should also be big O of K. Uh, Calculating the space complexity is pretty simple because we are having this string S and a string T which we create. The string T is generally created with the size of string S at that time. Yeah, maybe actually, uh, yeah, the space complexity will be only big of K because at any point of time, this string T, the length of the string T would be less than the length, like equal to the length of the string S at that point, and the length of string S would always be less than K. And as soon as it becomes greater than K, in that case, we will just go out of the for loop and return. So the string of the length of the string S should never exceed 2 into K. So that is why we can say that the space complexity should be big of K. Talking about the time complexity, this is a bit tricky for beginners because uh, it can look a bit confusing on how to calculate the time complexity here. Let me show a bit of try run here. Let's say if K is equal to 10, then initially the length of the string S would be 1, then the length of the string S would be 2, then the length of the string S would be 4, then the length of the string S would be 8, and then it will become 16. And when the length is 2 and we are applying an operation on it, okay, so let's start from the beginning. When the length is 1 and we are applying an operation on it, it will have one iteration. We will just have this for loop having one iteration, and then one iteration for the, like the same number of iterations for this. After that, when the length is 2, now the inner for loop will have 2 iterations. When the length is 4, then the inner for loop will have 4 iterations. When the uh, length of the string reaches 8, then the inner for loop will have 8 iterations. And when the length reaches 16, we don't apply any operation. Now, if you look at it, when the length of the string is 16, which would be approximately equal to k, we will just stop at that place when the string will have its size greater than k. The sum of all of the iterations which we had applied previously would be just the length of the string minus 1. Like if you calculate the sum of all of these, it will come out to be 15. And even if we apply an operation at this place, the length of the string will become equal to 32, and we would have applied 16 more iterations here. So it would have been 31 here. So overall, we can say that approximately there will be uh, in order of k operations, in order of k iterations. And I think that this might not be very obvious if you are looking at it for the very first time. And let me give you one example. When we say, like, if we have a vector of integers a, the part which I'm discussing now is out of the problem. So the problem A has been discussed. Now I'm just sharing something extra. Let's say if we are having vector of integers with name A, and you say A dot pushback, maybe 10 or whatever, and you apply this pushback operation again and again, then in the memory, at some place you were having some memory allocated for the vector. When it gets full, then it creates a new vector. It creates a new vector with double size and copy all of these values there. So the time complexity for pushback is like whenever we are pushing back an element, and then this thing happens where we are copying the vector into a new place. Something like this is also happening there, and overall time complexity for pushing n elements comes out to be big O of n, approximately n overall. Something similar is happening here. I was just willing to share some extra information. If you then get it, just ignore it. No need to worry. Okay, so guys, is this problem clear? Or does anybody have any doubt? If you have any doubt, feel free to ask it in the chat. I'm looking at the chat for your responses for now. And if it is clear, then please write clear in the chat. Yeah, you can call it as 2 into k minus 1. You can call the time complexity as 2 into k minus 1. But in general, like even if you have something like 10k, okay, 10k is a big deal, but even if you have something like 4k, we generally write it as big O of k, right? So that is why, just for simplicity, I called the time complexity as big O of k. But to be more accurate, you can call it to be something like this, though it won't also be accurate. There, the constant factor would be more than 2. Guys, please say yes or no in the chat whether this problem is clear or you have any doubt. If you have any doubt, then please ask it in chat. And if it is clear, then we can move on to the next problem. Okay, nice. Then let's look at okay, I messed up again. Okay, so this is the second problem of the contest, which says count the count of substrings containing every vowel and k consonants. Oh, okay. I think I wrote this name wrong everywhere. The problem says we are being given a word. Basically, we are being given a string with name word and a non-negative integer k. We have to return total number of substrings of word that contain each and every vowel at least once, and every like that substring should contain exactly k consonants. So we are being given a string with name word. We have to tell how many substrings are there such that that substring should have at least one occurrences of a, e, I, o, and u. All the vowels should come at least once, and along with this string word, we were being given an integer k as well. So the total number of consonants in this substring should be equal to k. Count of consonants is equal to k. I hope the problem should be clear. It is very straightforward. And let me take one example. A, E, I, O, Q, Q. The word is A, E, I, O, Q, Q. So in this case, we can see that since there is no U, obviously there would be no substring which contains all the vowels. So we don't even need to look at K. Like we don't even care about the value of K. The answer would obviously be 0. Let's look at the second string, second example. A, E, I, O, U. When the word is A, E, I, O, U, and K is equal to 0. So in this case, there is a substring which is actually the entire string, which contains all the vowels and it does not contain any consonants. Basically, the number of consonants is equal to 0. So yeah, there is one substring which contains all the vowels and 0 consonants. So the answer will be 1. You can look out for any other substring, but you see, none of the other substrings contain all the vowels. So there is only one substring which is valid. And then there is another example. This is a big string. And k is equal to 1. So the explanation has told us that there are three okay, maybe I can just copy and show this. Okay. Just 1 second. Yeah. So this is the given string in the example. If we look at the first substring, that is okay, there are too many substrings, we can't look at all of them, but let's look out for all the substrings which are containing all the vowels and at most exactly one consonant. So yeah, this is one substring, I, E, A, O, U, Q. Then another substring is here which contains all the vowels at least once, and no, this is not valid. We should have at mm, let me see. Yeah, this is another substring, and this is another substring. Yeah, there are these three substrings: A E I O U Q, Q E Q I E A O U, I E A O U Q. I don't think it matters. I believe you got the idea of what substrings we have to count and what we don't have to count. We should not have any other value than k number of consonants. Here k was equal to 1, and we need to have all the vowels. Okay, so obviously after reading the problem, you would look at the constraints, and the constraints are very small here. The value of word, let's say n is the length of the string, it is less than equal to 250. So it is already giving us an idea that maybe we can have something like n cube solution, because n cube solution would be something like uh, 2.5 cube into 1e6, and this should be around 15 or something. So it would be like less than 2e7 number of iterations in total. So yeah, just looking at the problem is giving us an idea that hey, we can have around n cube time complexity. So obviously you will try to think about the brute force solution, since you can have a very bad time complexity as well. So what can be the brute force? Okay, so guys, you have 2 minutes. Try to think of any way of solving the problem. Like, don't care about the time complexity or space complexities. Just forget about them and try to think of the simplest solution which comes up in your mind. You are allowed to use the brute force solution for the problem. The deal is you have to count the number of substrings such that number one, it contains all vowels. It contains all the vowels. Number two, um, it contains exactly k consonants. Let me start the timer. I will wait for exactly 2 minutes. As soon as you figure out uh, what to do, just mention it in the chat. I'm looking at the chat till then. Maybe I can start the stopwatch here. Okay, Manpreet wrote a solution, and yeah, this is correct. It will work. Very well, Manpreet. For I zero word length for zero. Faizan, that is correct. It will work. I think the time is over. I started the stopwatch around half a minute late. So we can continue. I think you have got enough time to think for what to do. The simplest solution which comes up to my mind is, as like, if I see this thing, that I can have a big of n cube time complexity, and I have to calculate the number of substrings such that it is satisfying some condition. I will try to think that if I have been given a string, like I'm not talking about a substring, I'm just talking about a normal string, and I want to verify whether these two things are valid for this substring or not. Can I do this? Can I do this thing in big of n? I'm just telling you a very simple way of thinking about how to solve the problem. If you had figured out that you can have big O of n cube time complexity, the first thing is, since you want to count the number of substrings, um, one thing which can come up in your mind is that maybe I can check for each and every substring. For each and every substring, in total there will be n into n plus 1 by 2, that is around big O of n square substrings. And now there will be this many substrings, which is in order of n square. So for each and every substring, if I can verify if it is satisfying these two conditions or not in big O of n time, in big O of n time complexity, in that case I can just use two for loops. Let's say one for loop for I, another for loop where j is starting from I and going till j is less than n, and then I can verify whether this substring is good or not, and if it is good, then I can increment the answer. Here I can have a big O of n time complexity checker. It is fine. So this is the simplest solution which is coming up to my mind. Now for a string, if you have to check for these two conditions, how will you do? You would like to have a set of um basically, you can have five booleans. Maybe you can have five booleans. Is a present? B is e present? Is I present or not? Is O present or not? And same for you. You can have five boolean variables, and whenever you get a, you will just make it true. Whenever you get I, you will mark it true, and so on. And you can have a variable which is count of consonants. Obviously you can give a better name, something like num consonants. So you can maintain a integer variable which would initially be 0, and whenever you get a consonant, you will just increment it. Right, this is the simplest thing which you can think of. And obviously, instead of keeping five variables, one better thing you can do is maybe have a boolean array of 5 length for vowels. Like, let's say you found a somewhere, then you will just go and mark vowel of 0 as true. If you found o somewhere, o is the fourth vowel, so you can just go to vowel of 4, sorry, 3. O is the fourth vowel, so we would mark the index 3 as true, since we are having 0 based indexing. And similarly for u, we can go to the fourth index and so on. So we can maintain a boolean array and an integer variable for counter, and we can iterate over this string. Whenever we find a consonant, we will just increment this thing. If we find a variable, sorry, if we find a vowel, we will go for the specific vowel and mark it true. I hope it makes sense. Guys, yes or no? Is this approach clear? Okay, nice. So another thing which you can do for having an even simpler approach is maybe just create a map or something, or maybe a set. Maybe you can create a set of characters st, and whichever character you find out in the string, just push it into the set. And at the end of the day, you should just check that st.count a, similarly for e, similarly for o, similarly for a e i o and u. All of these should be true. You can do this as well. Obviously there are a lot of uh, things you can do at this place. I just told you about the two simplest things I can think of right now. So let me, I can show you my implementation, but this is, I think, a bit complicated for some people. Maybe I can just implement it right in front of you. It would be even better in that case. So as we discussed, we want to find out each and every substring. So how do we find out each and every substring? We can have two for loops, two nested for loops. After that, the substring which is starting from I in the word, the substring starting from I and going till j, I want to check if this is valid or not, right? I want to check if this is valid or not. So now what I need is a set of characters st and integer num consonants. For now, I'm just naming it as count, a small name, and I will go from I till j, and I will insert the character, and I need to check if this character is not a vowel. Okay, so for that, I can have a character array, vowels, A, E, I, U, right? Um, though I generally recommend to create vectors. It's up to you if you want to create an character array. I generally recommend vectors instead of arrays. So you can have something like this, and maybe just run up another for loop here, and L equal to 0 to 5, and uh, bool is vowel, maybe false initially, and if word of k equal to vowels of L, then is vowel will become true, and uh, here you can just say that, hey, if this is not a vowel, then count will be incremented, and here uh, now we need to check if this substring is valid or not. So for checking if it is valid or not, maybe let's create a variable is valid equal to true, or maybe is valid equal to, yeah, maybe true, or maybe contains all vowels equal to true, and then if st.count a is 0, if it contains no a, in that case this thing should become false, and similarly you can do it for all of them, a, e, I, o, u, and Then you can at the end say that, hey, in case if it contains all vowels and the number of consonants it has, that is count, is equal to k, then answer should be incremented. This answer will be a variable which is initially 0, and you can return answer, right? Okay, it failed. Okay, nice. It's good that I tried to submit it. So yeah, the reason it failed is because we are not checking it in big O of n here. We are using a set as well, which is having a lot of constant factor, and uh, I don't think it should be about the time complexity, but maybe because of the constant factor. So we should not use set, and instead we should use something like uh, a vector of integers for count. Uh, Maybe uh, frequency with, let's name it as frequency. It will have size 26, and we will just say fric of word of k minus a to be incremented, and then at the end of the day we should here check if fric of a minus 26 is equal to 0 or not, and a, e, I, o, u. Using a set was definitely simple, but I forgot about the time complexity there. Okay, and a, e, I, o, u. So maybe it should be correct now. Okay, this is having some issue now. E, E, I, O, U. Oh, sorry. Okay, yeah, it is working now. So earlier the problem was we had used a set, and you see set generally has the logarithmic time complexity, but log of 26 should not be a problem. The main problem would have been that uh, it will have the constant factor. So using a set was not a good idea. Okay, let me look at the chat, and guys, please tell me if this problem is clear or not. If this is clear, then we can move on to the third problem. And yeah, there is one more thing. This problem can actually be optimized to big O of n square time complexity as well. The idea is once you uh, check for this substring uh, and you want to check for the next substring, currently we are iterating over the complete substring, even if we had checked this substring just a while ago. So what you can do is, for optimizing this to big O of n square, uh, you see, we don't want to have this complete iteration, and the way we can remove this complete iteration is uh, by making sure that uh, we can have these two variables outside. If we have them outside the for loop, in that case we won't really need to go from I till the jth index. Like, you are iterating over this complete part to find out this fric array and this count variable, right? But you had already calculated till this part. So if you declare this fric and count array at this place, then you already have uh, their values till this point, and you just need to add one variable, add one character. This is a very good way, like a very common way of optimizing because of n cube time complexity, because of n square in case of subarrays and substrings. So we don't need to have this for loop anymore. Instead of this k, we will have a j here, and word of j. Okay, so it has been implemented. We are going over everything. Yeah, I believe this should also be correct. Okay, so this is how you can optimize a big of n cube time complexity solution to big of n square if it is valid. Like if it is possible to make sure that uh, you can add just one thing. Like if you have the data which you had calculated in the previous substring, if by adding one variable you can obtain the data for this new substring, then it is possible, which is most of the times the case. Maybe not every time actually. Yeah, and as someone suggested, if the count becomes greater than k, then we can break as well. We can have more. We can just have a little bit of more of, like we can optimize it a bit by adding something like this. Okay, I hope this is clear. Many people have said that it is clear. So the time complexity here would be obviously big O of n cube, and the space complexity here should be big O of 1, I think, or like this is all which we are creating, the extra space which we have taken. So it should be big O of 26, or maybe we can call it as big O of 1, the constant time complexity. Okay, let's move on to this third problem. The third problem is nothing but the second problem with higher constraints. The constraints are gonna be more tight now, or like less tight for this, and the time constraints would be more tight for us now. So in the previous problem, n was less than equal to 250. Now n is less than equal to 2 into 10 raised to the power 5. Right. This is the case. So n is less than equal to 2e5, which gives us a hint that maybe we have to solve the problem with big O of n, or big O of n square root n time complexity, or big O of n log n, or maybe big O of n log square n. One of these time complexities, like we are getting this as a hint from looking at the time constraints. Obviously, we cannot have something better than big O of n, because we will have to at least iterate the string at least once. So the time complexity can never be better than this. And anything worse than these would not work. Uh, yes, yeah, so we already know how to solve the problem with big O of n square time complexity. Right, we want to optimize it a bit. Now, let's recap the problem. The problem was they had to they had to find the count of substrings such that number one, it contains all vowels. it contains all the vowels. And number two, uh, number of consonants equal to k. Okay, so we have a problem related to finding the count of substrings, and we want to do it in a complexity better than big O of n square. So if you had attended the previous PCD which I took for Leetcode, we had got a similar problem in which we had something to do with the count of substrings, right? And there I told you that when you want to find out the count of substrings with a time complexity better than big O of n square, it is always beneficial to at least think about optimizing it with either something like binary search, which might involve prefix sum arrays. Like keeping prefix sum arrays in your mind is also good, or sliding window. If you have problem related to finding the count of substrings where the substrings can be of any size, generally these are the three techniques as per my experience which help me to solve the problem very easily. So this is something I always do, and I always recommend others as well, that maybe you should think about these techniques and it can help you to speed up during contest. Because if you directly think whether I can apply binary search or not, or whether I can apply sliding window or not, it would obviously help you to figure out how to solve the problem very fast. Um, okay, so for any substring, for any substring, there are two things. There is a starting point and there is an ending point, right? Now, whenever uh, I talk about applying binary search, though binary search can be on multiple things, but generally the way in which I apply is I try to fix a starting point or ending point, one of them. So let us say I fixed the starting point. By this, what I mean is I will only talk about finding the count of substrings where they're starting from here. So substrings like this one, this one, this one, and so on. All of these substrings are starting from here, and they can end at any place. I don't really care about it. It can end anywhere till the last, right? Now, for applying binary search, like if you want to check, or like you don't even need to think about just binary search. The main thing is when you fix starting point, you want to find out the count of substrings. Try to think that if this substring is satisfying a condition, maybe let's talk about only this condition. Let's forget about the second condition and try to think of how you could find out the count of substrings where the substrings contains all the vowels. Let's say if this was the problem. So let's say if this contains all the vowels, can I say that this will also contain all vowels and this will also contain all vowels? Guys, tell me in chat, what do you think? If I can say that this substring contains all vowels, if this contains all vowels, then these two will also contain all vowels. I'm waiting for your response in the chat. Okay, so One of you said yes, and another one said no, and none of the other guys replied. For now, I'm just assuming that you could not understand how it will happen. Let me give you a explanation for this. If I have a substring and I say that it contains A, E, I, O, uh, and U, it contains all of these. And then I said that hey, I incremented, like I added one more character to the string. Now this is my substring, like this is my new string. So it contains all the characters which were present earlier as well, right? It contains all of these, like it must contain all of the characters which the this string contained. So if this substring contains all the characters and this substring contains the complete previous string substring, so obviously all of these vowels would come in this substring as well, in this substring as well, and so on, right? Similarly similarly if this substring does not contain, if this substring does not contain all vowels, then this will also not contain all the vowels. I hope this should also be clear, because if it had contained all the vowels, then this would have also contained all the vowels. And it does not contain any vowels, so it must also not contain all the vowels. Clear? I hope it is clear. In case if anybody has any doubt at any point of time, you can ask it in chat. That is the point behind having a live stream. So feel free to ask any doubts. For now, we understood that uh, we can apply a binary search. Like if we know about the starting point, then we can apply a binary search for the ending point. The ending point would be anywhere from here till here. Basically, a substring might have only one character, though obviously you know that for one character, that substring will not contain all the vowels. The substring size must be at least 5. Um, okay, so you can apply a binary search for these to be the ending points. Like this is the minimum smallest possible value for ending point, and this is the maximum possible value for ending point. Now let us say this is the mid, and you have basically got uh, this substring for which you want to check if it contains all the vowels or not. How will you check? Sir, what is the starting point? This like we can have a for loop for starting point. The starting point can be anything from 0 till n minus 1. For each and every possible value of the starting point, we will try to find out. Such an ending point, like for each s, we will find the smallest e such that the string from s till e is valid and the substring from s till e minus 1 is not valid. If we find something like that, if we figure out, let's say that this is the smallest possible value of e for which this substring is valid and all of these are invalid, then I know that hey, the count of substrings which are there having ending point greater than equal to this e would be valid. This is the idea. So if we figure out such an e, then the answer would be nothing but n minus e. Depending upon how you declare the e. If you are counting e in the substring, then The answer is n minus e plus 1 for the number of substrings which start from s. Now the deal is, for any substring from s till e mid, how will you find out whether this is valid or not? Whether it contains all the vowels or not? How will you find it out? So you can do it very easily by creating a prefixum array for all the, like, create a prefixum array with size something like 3 of n plus 1 comma ch. So sorry, pre of n plus 1 comma 26. So pre of I comma j will tell you that in the string from like among the first I characters of the string, which is from index 0 till index I minus 1, how many times does the character j come? Does the jth character come? So pre of 10 0 will tell you that in the first 10 characters of the string, how many times the character a is coming. And similarly, you can have for one, for like for b, c, and so on. Or you can create a prefixum array in such a way that pre of 0 will contain for a, pre of 10 0 will contain for e, pre of 10 2 will contain for I, 3 for O, and 4 for U. This can be a optimization. So because you don't really need to calculate the frequency of any other character. So in this way, you will be able to find out whether a is coming up or not, because for each and every character you are having a prefixum array. So with the help of that prefixum array, you can actually find out whether a is coming up in this substring or not, whether e is coming up in this substring or not. Same for o, same for I, same for u. Right? You can check for each and every character in this way. Sir, how to think about binary search, because it does not come in mind. That will get better with time as you solve more and more problems. In my case, I have solved a lot of problems. That is why this was the first idea I got in mind. But for you, you can just try to remember in the way I told you, that if you have a problem related to finding the count of substrings and you have to do it in a time complexity better than big O of n square, then it is worth to think about the binary search or sliding window technique. I first of all try to think about the binary search technique generally, and then sliding window technique. Sliding window technique would be a bit more optimized than binary search technique, but it would be a bit more uh, complicated as well. It would be a bit difficult to think directly. Like if you think about the binary search technique first, then thinking about sliding window is simple. Okay, so guys, are you with me right now? Have you understood till this part, or have you got stuck somewhere? Have you understood that how we could solve the problem where we had to find out the count of substrings which contains all the vowels? What we could do was, for each and every s, we could apply a binary search for finding out the value of e. We know how to check whether a substring contains all the vowels or not. So we could find whether the substring from s till e mid contains all the vowels or not. And yeah, that's it. We could figure out the smallest value of e such that it this substring is valid and the previous one is not valid. Yeah, basically you don't even need to say this in the definition. If you say that you want to find out the smallest value of e such that this is valid, it is sufficient to say. Yeah, very well. So if you have understood this part, now the task is you have one more condition, that is the number of consonants. Now, as we did earlier, like we had a big problem, we tried to break it down. We broke it down to first of all think about solving this problem, then think about solving this problem. Now let's do the exact same thing again. Let's forget about the count of vowels and only think about the number of consonants. And we want to solve this problem using binary search so that we can apply both of these conditions at the same time. Basically, we want to solve a problem in the same way for this and this so that we can apply both of these conditions at the same time. Now, let's say we have fixed the value of s. Now we want to find out how many substrings are there which contains exactly k number of consonants. For a specific s, let's say these are the substrings. Okay, so let us say I tell you that this substring, this one, contains k consonants. Guys, can I say that this will also contain k consonants, this will also contain k consonants, this will also contain k consonants? Can I say this? Yes or no? Apparently, I don't have a stopwatch. Exactly. Faizan is correct. They can have more as well. Like if this is a consonant, then this one might have k plus 1 consonants. This might have k plus 2 consonants. And if this is a vowel, then this might also have k plus 2 consonants. So there is no guarantee that there is no guarantee that if this guy had k consonants, then they will also have exactly k consonants. They might have more as well. Right. So the solution, like the approach which we used in the last, which we used in the last sub problem here, won't work here. Right. We need to think about something else. Let's try to keep it similar to the previous one. That if I change the condition a bit differently, that if this substring contains greater than equal to k consonants, then this will also contain greater than equal to k consonants. The same for this and the same for this. Yes or no? This will also contain greater than equal to k consonants. The same for this guy, the same for this guy. Guys, yes or no? Forget about the problem, just tell me about this sub problem. That if this substring contains k consonants, then this will also contain at least k, or yeah, at least k consonants. This will also contain at least k, this will also contain at least k. Now the problem is, I don't want more than k. I want to have at least k consonants, but not greater than k consonants. है ना? So I can apply one binary search to figure out the smallest e for which it contains at least k consonants, and I can do the same thing, another binary search to figure out the largest value of e such that it contains less than k number of consonants. Does it make sense? The largest value of E such that it contains less than k consonants. Let's say, let's call this previous one as E1 and this one as E2. So E1 is the smallest endpoint such that substring from S till E1 contains greater than equal to k consonants, and E2 is the largest one, largest endpoint such that from the substring from S till E2 contains less than k number of consonants, less than equal to k number of consonants. Then for the starting point from S, there will be E2 minus E1 plus 1 number of substrings which contains exactly k number of consonants, right? So now it is like you had a substring where this is the starting point. You got three different things. From the first binary search for containing all vowels, you got E, which told you that hey, this substring contains all the vowels. So all the next substrings, all the bigger substrings will also contain all the vowels, right? Then you got E1. That is the first place where you got k consonants, and for all the other substrings bigger, you will get at least k consonants. And then you have E2, which tells you that this is the largest substring where you have less than equal to k consonants. After this, you will have more than k consonants. So we have all this information. Now I will give you guys 2 minutes. I will give you guys 2 minutes, and you have to try to think of how you can use this information to find out the number of valid substrings which satisfies both of these conditions at the same time. And yeah, that is it. All the number of, you have to find out all the substrings starting from S and satisfy both the conditions. You said answer plus equal to E2 minus E1. Okay, there is one more thing. Among these E1, E and E2 which I have written, you know that E1 would always be less than or equal to E2. In case if there is no valid value of E, in that case, these E1 or E2 will be equal to N. And this E can be anything. Like this E might be greater than, like this E might lie here, this E might lie here, or this E might lie before even. All these three possible all these three things are possible. One thing is E might be less than even. Next thing is um, E might be lying between E1 and E2. And the third possibility is E might be even greater than E2. Guys, try to think. Okay, I think You had enough time to think. Let me tell you about the idea. The idea is the substring, like the valid substrings. Uh, Maybe let's call this as e dash for now, or yeah, let me call this as ev for now, because this was a condition for the variable, the ending point for the variables. So all the substrings, all the substrings s comma e would be valid where e should be greater than equal to ev, e should be greater than equal to e1, and e should be less than equal to e2. Right? This is the main idea. That's it. This is the main idea. You need to find out how many possible values of e are there such that all of these three conditions are true. So e should be greater than equal to the maximum of e1 and ev, and e should be less than equal to e2. So let's call the maximum of both of these as first, and let's call this e2 as last. Then the valid substring starting from s would be equal to last minus first plus 1, the maximum of, or maybe, yeah, it would be equal to this if first is less than equal to last. So we will have to write up a condition here. There is a condition that, hey, if first is less than equal to last, then this is the number of valid substrings. Does it make sense, guys? Yes or no? Do you have some doubts, or is it clear? I try to go very slow so that it is as clear as possible. Yeah, one more thing. What do you have to say about the pace? Do you think I'm going very slow? Should I go a bit faster, or you want me to go at the same pace? I'm waiting for your responses. Okay, you want me to go a little faster? And what about the problem? Is the problem clear, or you have any doubts? If you have any doubts, then feel free to ask. I will just answer them right now, at least for the first two problems. Uh, Actually, I went slow for the first two problems intentionally, because if someone is watching the PCD and wants to look at the first two problems, then most likely he's a beginner. So that is why I considered to go very slow for the first two problems. Okay, I used a different approach. Okay, so did you use sliding window? I made a suffix array which keeps track of the number of vowels starting from every index. Then I implemented the sliding window. First, okay, that's nice. Yeah, that is looking nice. There can be more ways for solving the problem. Let me give one example. This is one way of applying the binary search. There can be one more way for applying the binary search, and that is to have uh, like, instead of applying a different binary search for finding out this EV and then for E1, you can find out EV and E1, the maximum of both of these in a single binary search. Like, while checking for any mid value, apply both the conditions that it must contains at least k consonants and it must contains all the vowels. For checking how many consonants are there, you can again use a prefix sum array. You can again create a prefix sum array to keep track of the number of consonants. So it can be like, at this place, you can keep track of how many consonants are there in this whole prefix. In my case, in the implementation which I did, uh, as you know that I had created a prefix sum array here with size n plus 1 and 5, where this 5 was for the 5 variables. Instead of keeping it 5, I kept it 6. 0 is for A, 1 is for E, and then for I, O, and U, and then 5 is for all vowels. Basically, it will tell you about the number of total vowels you have got till now. So the number of consonants in S2 E1 would be equal to with the help of prefixum arrays, you can get the number of vowels in S2 E1, right? And you know that the total number of characters in S2 E1 is nothing but E1 minus S plus 1. So from this you can just subtract this value and you will get the number of consonants. This is live. We are doing a live stream right now. Yeah, so what we could do here is we can do the problem in 2 binary searches as well, and then talking about this binary search for figuring out the largest value of E2 where the number of consonants is less than equal to k. Instead of this, you can apply a binary search to figure out the first value where the number of consonants is greater than equal to k. So you will have to, like all the binary searches would be trying to find out the smallest values only, but this one is also fine. The way which we discussed, this is also fine. And yeah, you can optimize the solution by using a sliding window technique. The reason we can apply by sliding window here is because for every starting point, like when this is the starting point, let's say this is S1, you got some E1 and E2, where by writing E1 I'm talking about the maximum value of E1 and EV. Instead of that, I'm just writing E1. Then let us say now you want to find out E1 and E2 for this S2. Okay, I should say it in a different way. Maybe I can use some. Okay, so for this is the array. This was your S1, and you got E1 and E2 like this. Now let us say this is your starting point. You have incremented your starting point. Your E1 will either go towards right or will remain at the same place, right? Because you have removed a character. So E1 will never shift towards the left. It will either go towards right or it will remain at the same place. And the same thing goes for E2. When this thing is valid, you can be sure that hey, you are having 3 variables only. So instead of applying binary search for E1 and E2 again and again, maybe you can just keep track of E1 and E2, the values which you had last time, and see if you need to increment them or not. And if you have solved a couple of problems using sliding window, this would have been enough for you to be able to know what to do. For now, I'm not discussing complete approach for sliding window, otherwise the PCT will go very huge. We have to discuss one more problem after this. So is it fine if I leave it this place? Have you got some idea of why sliding window will work? Like, yeah, even if it didn't make sense, you can just try to use sliding window, and you will definitely get some text editorials at Leetcode for using sliding window. And if you have watched my previous PCD, there I actually discussed of how to use sliding window technique if you have already implemented prefix binary search and prefixum technique. So maybe you can take reference from there as well. Okay, so guys, shall we go to code or do you want me to discuss this one? You have two options, code or discuss sliding window technique. I believe code is better. Otherwise, the PCT will be very huge and the ones watching the recordings won't be happy. Okay. What about others? What do you guys think? Okay, let's go to the code. Okay, so see, we want to keep track of all the vowels, right? And we need a prefixum array. Now, since the size of the prefixum array would be quite huge, um, this is containing around 1e6 elements, actually more than that. You know, it is containing 12 into 10 raised to the power 5 because the dimension is 2 into 10 raised to the power 5 elements in this dimension, and we are having six such rows, so the size is pretty huge. So it would be a good idea to declare it globally. That is why I have declared it globally. It can have significant impact on the runtime, and that is why I've declared it outside. You can try to declare it inside. I have seen it a couple of times that declaring the uh, big arrays globally can increase, like optimize the time complexity, optimize the runtime by around 10 to 20% sometimes, and sometimes even more. So that is why I've declared it globally. And here we are calculating the prefixum array. This is a simple thing. Here we have created a vowels array, and since we want that if the character is A in the string, we want to update P of I0. If we get a character B in the string, then we want to update P of I1. Sorry, not B, but E. And similarly for I, we want P of I2 and so on. So I just created a simple function which will take up the character as input, and if this is a vowel, then it will return the index of the vowel in this array, and otherwise it will return -1, which means that the given character was not a vowel. So with the help of that, I will be creating a prefixum array, and I've created a function with name getCount, so that whenever I want to find out the count of some vowel in some range from L to R, I don't need to pass the I don't need to write this thing again and again everywhere. I can just call the get count function like this. So it makes things a bit easier sometimes when we have to uh, when we are writing this thing again and again. It can be better to just have a function to keep your code cleaner. And then I'm having some functions. We will look at them later on. Here is the main logic. We will go for each and every starting point. These S are nothing but the starting. These I are nothing but the starting points. So in the code I have used the word I for it, and I will calculate the first and the last positions as we have been doing here. This first and the last are nothing but the maximum of EV and E1, and this is E2. So we are calculating that, and in case if this first is less than equal to last, then answer plus equal to last minus first plus 1. This is quite obvious. Now the thing is, how will you get the first position? For that, we are having a simple binary search where the condition is that we should have all the vowels from start to M. in the substring from start to end. The way we will check if we have all of the vowels from start to end is by using the prefix sum array like this. We are checking for each and every vowel. And for checking the number of consonants from start to end, we can just say that, hey, in the substring from L to R, there are total of R minus L plus 1 number of characters. And this will tell me about the number of total vowels from L to R. So subtracting this will tell me about the number of consonants. It should be greater than equal to K. So this is how I will get the first starting point. And I'm just doing the exact same thing here. The only difference is I don't really care about the vowels now. And I have to find out the uh, end point, the last point where the number of consonants is less than equal to K. This is how I will get the last variable. And after that, you know what we are doing. So that's it for this problem. The time complexity would be a bit weird here because first of all, we are creating the prefix sum array. So it will have 26 into n, oh sorry, 6 into n time. After that, we are going up for each and every value of I. So n into, we are applying two binary searches, and each and every binary search will have log n iterations internally. So log in there, and these check conditions, like this check condition will have a for loop of 5 size inside it. So it will be like 5 here. So this will be the time complexity. This should be around 1e6, and this should be around 4e6, and multiplied with 5 will make me around 2e7. If I have not made any mistake, then the number of iterations we are getting is around 2e7 or something. I hope I have not made any mistake here. Yeah, basically it would be around something like this only. Talking about the space complexity, we have only created this prefix sum array. So space is only 6 into n, which is good enough. So guys, should we go on to the next problem, or do you have any doubts in this problem? If you have any doubts, then feel free to ask. I have been emphasizing so much on this that you can ask any doubts. That is the whole point behind having a live session. Just write in chat. Should we move on to the fourth problem, or do you have any doubts? Maybe let's have a 2-minute break. Okay, let's have a 2 minutes break so that you can also relax and I can also give some rest to my throat. And in the meanwhile, you can grasp the approach which we had discussed. Maybe you can uh, get some good ideas by looking at my code like this one. This is a really good thing. Or maybe this thing. Did you get PPO on Google? Yeah, I did get. I got PPO. Okay, so this will be the next problem which we will discuss. This is a follow-up problem of the first one which we had discussed. The difference between the first problem and this problem is, first of all, the value of k can be very huge this time. Secondly, uh, we have been given two type of operations this time. So in the first problem, thank you Harshit. In the first problem, if you had a string like ABC, it will definitely become equal to ABC BCD. But this is the fourth problem in which this ABC can become into two things depending upon the operation. If the operation is of type 0, then it will become ABC ABC. Otherwise, it will become ABC BCD depending upon the type of the operation which we apply. That's it. That's the only difference. And one more thing, earlier k was less than equal to 500 or something, but this time k can be less than equal to 10 raised to the power 14, which is a very huge value. Okay, so guys, is the problem clear? Yes or no? Is this problem clear? Since you have already solved the first problem, even those who would watch the video on YouTube, you would have solved the first problem. So understanding the fourth problem should not be difficult. Uh, the examples, let's discuss about the examples. If you had something like A, and the operations are 0 0 0, and you want to find out the k equal to 5. Okay, the value of k can vary and this will remain the same. So k is 5 here. Then in that case, initially you had A, you applied the type 0 operation, so it became AA. Then you again applied the type A operation, type 0 operation, so it became AAAA. Then again type 0 operation and it became AAAA, AAAA. And now you have got more than 5 characters. So you will just look at the fifth character, that is in A. So this is our answer. And then in the next problem, we have k equal to 10. The operations are 0 1 0 1, which means that the string A will become AA, then it will become AABB because of the type 1 operation, then it will become AABB, AABB because of the type 0 operation, and then it will become AABB, AABB, BBCC, BBCC because of the type 1 operation, right? Something like this. And we have to tell the 10th character. So here our string has gone beyond the length of 10. That is why we can look at the 10th character, that is this B. So our answer will be B. Is it clear? You guys at least say yes or no. It would be better in that way. The more interactive session we have, the better it would be. Otherwise, it would be equivalent to the way I create the recorded videos and you watch them later on. So I think that watching the video live won't be beneficial for you if you don't stay, like if you don't take the benefit of being watching live. Okay, so one thing is clear, we will have a string. It will become of double size in the next turn. the next character we get might be same or it might be bigger one. Then again, your string will become of length double. Then not like this word. Again, your length. Again, the string will become of double length, and it will keep on doing. So let us say the value of k was equal to 20. Let's say this is the case. Initially, the length of the string was only 1. Then the length of the string was 2. Then the length of the string was 4. Then the length of the string was 8. Then the length of the string was 16. You can draw, but yeah. And then the length of the string will become 32, which is greater than 20. So yeah, we can look up for the string. You know that till this point you had 16th characters. So your 20th character will lie somewhere around here. That would be the 4th character in this, right? In the other part, in the other half of the string, right? In the later half of the string, you will have your kth character coming up at this place. But how will you identify which character is present here? Any ideas? Would anyone like to tell about any observations you can see at this place? I'm waiting for your responses. Someone might like to say something. Okay, the idea is simple. Let's try to backtrack. You know from where this character would have come. This character would have come from the 4th character here. Now, depending upon the last operation which you applied, like earlier you had length 1, you applied an operation of type 0 or 1, then again type 0 or 1, then again type 0 or 1 operation. In both the cases, you are copying at least. So the string is becoming of length double. Now, if the operation was of type 0, then this character would be equal to this character, right? Otherwise, this character would be equal to this character in case if the type was 1. If here the character is C, then here the character would be D and so on. So depending upon whether here is a 0 or 1, if you know this character, then you can figure out the current character. Does it make sense? Guys, is this thing making sense? That this kth character came from somewhere on the left half. So instead of trying to figure out this place, like let's say I had a function. Let's look at the problem. Okay, so you had a function kth character. Let's say you had this function kth character being called for 20, right? And the type of operation here was, let's say, 0. So can I say that now I can just return, hey wait, when did it again? Can I just say that here I will just call this kth character for 4 now? I can just apply recursion here. Does it make sense? I can simply apply recursion here. But what if it was 1? In case if the last operation was 0, then it was very simple. But what if the last operation was 1? What will you do in that case? Then again, it is still simple. You can just say that um, you will say let's say you got the character, you got the result for 4, you know about that character. Now if that character is Z, then return A, else return rest plus 1. Or maybe you can just say one more thing, where typecast it, right? Does it make sense? You can, for finding out this value, we notice that this was being copied from here. If it was a type 0 operation, then this value should be equal to this. Otherwise, this should be one greater than this guy. So you can just find out this thing. Now, whatever function was being called for this guy, obviously that same function can be called for this guy. So just call that recursive function, find out this value, and you can then increment it once, because in the type 1 operation you have to increment it once, right? Now the deal is, how will you figure out whether this is the fourth guy or which guy? This is the doubt. And what will be the base case? So the base case is pretty simple. First of all, let's talk about that then. If k is equal to 1, you can just simply return A, right? We are going back, so I guess we should do char minus 1. No. With the help of recursion, we have calculated this thing. We have calculated the kth character of 10. Sorry, kth character of 4. But we had to find out the kth character of 20. If we had applied a type 1 operation when the string was at this place, if this was a type 1 operation, then this character, if it was C, then we would have written D at this place. So we will have a plus 1. Fazan, does it make sense now? Great. So the base case is pretty obvious. And yeah, this is K. This is the current K which we have. Let's call this thing as maybe J. Let's call this variable as J, for which we will apply the recursion. So what we want to do is, we want to find J. Once we have found J, and one more thing which we want to do is, we want to find out whether it was a J, like the type of operation. So we want to find J and type as well. Let's say if we have found J and type, then the thing is, if type is equal to 0, then you can just simply return kth character past J here. Else, like you don't really need to write else here. Obviously, it will come here. So if the kth correct, if type was 1, in that case, you can just say that, hey, if yeah, you can just say char result equal to kth character of J. And now if res equal to Z, then return A, else return result plus 1. I believe that this much should also be fine. Otherwise, you can write char of result plus 1 to typecast as well. Typecast is it as well. Now, the recursive function for this will be called. So, okay, so somebody is saying, I thought we are going from 20 to 1. Yeah, we are going for 20 to 1. Here the k was equal to 20 for us. After the recursion, the recursive function having k equal to 4 would be called. Then a recursive function for k equal to 2 or whatever would be called, let's say 2. Then for k equal to 1 would be called. Okay, so now the deal is how will you find out j and how will you find out type? And as you might have figured out, it is also something simple. If you try to remember the dry run which we had done earlier, as long as your length is less than k, you will make it double again and again. At some point of time, your length will go greater than or equal to k. So at that place, you know that there are two halves of the string. So if you say k minus len by 2, this will tell you about this much. K minus len by 2, right? This will tell you about the position of this character in the second half, right? This is what will be equal to j for us. This will be our j. And the operation on which, after doubling the length of the string, this thing happened, that will be the operation value. So we can do something like this. Int n equal to op dot size. Yeah, by the way, in the problem, they had initially written the vector with them operations, but I just wrote it as OP. Because this will be a short name. So I can go on for I can just iterate over this array, and if okay, I will just say length multiplied by 2. This long length was initially equal to 1. I'm just simulating as things will happen. Length will become twice again and again, and at some point of time length would have gone greater than equal to k. So you know this type here, type is equal to op of I, and j is equal to k minus len by 2. Then from here on you can just return whatever we had to return, like you can just have all these return statements, or maybe you can just have a break here, and you can declare these variables outside this j and this type variable, and then you can have all those return statements and everything here. Guys, does it make sense? For the ones who are watching it live, please tell me yes or no. Maybe I can code it as well. In my case, the code which I had written was iterative. I did the exact same thing, but I wrote an iterative code instead of the recursive code. But I can write a recursive code as well for you. So we will have int n equal to op dot size, and then we can iterate over the array. We will have long len equal to 1, and we will have one more thing. Yeah, the next k. Instead of writing j, I'm just calling it as next k for now. So we will say len being multiplied by 2. If len becomes greater than equal to 2, then okay, we need type as well. Type will be equal to OP of I, and we will have this next k equal to k minus len by 2, and then break. And then here you can say that char result equal to kth character for next k, and you will pass OP obviously. And then if uh, type equal to 0, then just return char, the return res. Otherwise type is 1, so if result equal to z, then return a, else just return res 1, res plus 1. Okay, it's not working. Maybe we have to write char, though I don't think the error is because of this. Probably I missed something else. Uh, okay, I forgot about the base case. Yeah, you will have a base case here that if k equal to 1, then return a. Okay, it's working fine. It failed somewhere. What did I miss? Okay, I got it. Uh, this must be a long next k. Yep, this is fine. Obviously, when you are coding during the contest, you won't make this many wrong attempts. Right now, I just wanted to do it as fast as possible and didn't care about penalties. Okay, so guys, is it clear? Talking about time complexity, what can be the worst case? The worst possible case is this next k to be as large as possible. You see, this here k would also always be greater than len by 2 and less than equal to len, right? You want this thing to be as large as possible. So one thing I can think of is if k is always equal to len, so in that case this next k would be just half of k. So there will be log n times the recursive function being called. So we will have we go of log n times the function being called, and whenever the function is being called, you are having this for loop. Even though the for loop is of size n, it won't really go completely because your length will go, like length will become double again and again and again as long as this length is less than equal to k, sorry, is less than k. So you will have at most log n iterations in every function call, sorry, log k. So this is even worse than the worst possible case. This might be the time complexity. Talking about space, um, it would be just big of log k because of the function recursion. Since there will be at most k function calls in the stack at any point of time, so this will be the space complexity due to recursion. Okay, so guys, is this problem clear? Please say yes or no. Or do you have any doubts? Until then, let me read the chat. And by the way, if you want, you can even ask me some doubts related to some off-topic things if you want. Off-topic, we also got an opportunity to give interview for Google Summer Internship. My last interview was on 30th August, and I'm looking for result on 12 September. Asking for the result, which you like, wait for the notice. Should I mail it back? It's more than 2 weeks of past to this week. Maybe we can discuss about this off stream. You can message me on Discord, Harshit, and there we can talk about it. Uh, For a simple answer for your question, you should mail her, according to me. Okay, so guys, anybody having any doubt related to this problem or related to any other problem? And how was this stream? Would you like to give some feedback? This time, I think in this stream, the uh, audio quality would have been better than the last time, better than the previous stream. The video should have been significantly better. The stream, the screen share. And for the explanation, I'm not sure of how is it in comparison to the last one. So please tell about this in the chat, and I will try to uh, make the audio quality a bit more better from the next stream. So thank you for watching the stream, and if nobody has anything to say, then bye bye.